Hello, my name is Emma Rogers. I just wanted to thank you for taking over my class today. Today they're going to be doing a review of matching parent functions. The SOL is that the student will be able to recognize the general shape of this function's families and will be able to convert graphic and symbolic forms of functions. A transformational approach to graphing will be employed. Graphing calculators will be used as a tool to investigate the shapes and behaviors of the functions. This is for the grade level 10, and the learning objectives are: given the review, the student will be able to identify the basic x squared, x cubed function correctly with the accuracy of 3 out of 3, and also given the review, the student will be able to identify the sine x, cosine x, and tangent x correctly with an accuracy of 3 out of 3. Now we're going to look at a Nearpod that I created that you'll be able to use as the review today. Alright, so this is going to be the basic setup of it, and then you're just going to go through this with them. And this is just a review of what that y equals x is the 45-degree line through the origin, y equals x squared is parent function of a quadratic equation and has the shape of a parabola, y equals x cubed is the equation of the parent cubic function, and it makes kind of like a humped looking shape across the graph. This is their first thing that they're going to be able to do. They're just going to draw their own y equals x on the graph. So they're just going to take their pen and then just do basic. I know this looks pretty bad, but oh well. And then just, straight through. And this one, they're just going to answer the question. And this one is all up to them of what they think it looks like. Just a guess. That one doesn't have to be correct. And this is a review of like the harder trig ones. They just need to focus on how it oscillates, and the origin of the function is at 0, and the same for this one, it oscillates and the origin of the function is at 1. And for this one, how it's undefined at every pi over 2 and 3 pi over 2, and the function is 0 at every pi. So this one, they are going to follow their instructions on the previous one, and they're going to graph their sine and their cosine, which I prefer if they do it with different colors, but in the end it's going to end up looking like that, kind of. And this one's going to be a fill in the blank. For the tangent function. And that's pretty much it. Alright, I just want to thank you again for helping us out today.